A very good evening, good afternoon, and good morning to all our audience and our esteemed guests who joined us from across the globe. It is indeed my honor to welcome you all to this Young Professionals Global Summit 2020 organized by Young Professionals Affinity Group Bangalore along with IEEE Bangalore section under the aegis of IEEE Bangalore Technology Conclave that is going on since November 3rd this year. So this technical extravaganza, we have a great lineup of events and speakers who are young technology leaders from across the globe. We are now here at the inauguration and we have with us esteemed chief guest Dr. Maike Luiken, guest of honor Dr. Ramakrishna Kappagantu, and IEEE YP Bangalore past chair Mr. Manjunath Iyer, along with BTC chair and chair IEEE Bangalore section Mr. Puneet Kumar Mishra, and Young Professionals Affinity Group Bangalore chair Dr. Appaji. I request Dr. Appaji to take over and welcome the audience and deliver the welcome address.
So Manju, are you joining from Lalbagh?
Giving a virtual feeling that I'm outside.
So hello everyone.
Can you switch on your video if it is okay? Thank you, sir. Yes. Yes, Ashwinin, please go ahead.
So hello everyone. Namaste to everyone here. It's my pleasure to welcome our eminent chief guest and keynote speaker for today, Dr. Maike Luiken, IEEE Canada Past President 2021, IEEE Vice President-elect, Chair-elect, Member and Geographical Activity Board, IEEE Canada Foundation, Member of Board of Director 2020. So we welcome you, madam. I also would like to extend a warm welcome to Dr. Ramakrishna Kappagantu, our guest of honor, past director, IEEE Region in Asia Pacific, MGA VC membership. I welcome you, sir. We also have with us Mr. Manjunath Iyer, our past chair of Young Professional Affinity Group Bangalore section. I cordially welcome Mr. Puneet Kumar Mishra, General Chair, Bangalore Technology Conclave, Chair of IEEE Bangalore section. I also welcome all the eminent speakers and guests from all over the country who will be sharing their knowledge and their vast experience during this summit. So last but not the least, my heartily welcome to all our participants who are eagerly waiting to gain a lot of knowledge from this summit. So this IEEE Young Professional Bangalore, in association with IEEE Bangalore section, it has come up with a unique event, I can say. So Young Professional Global Summit 2020, this two-day virtual experience will be featuring the young achievers across the diverse domains of technology and entrepreneurship. And this summit is initiated to promote the benefits for young professionals, graduating and graduated students to nurture the technical and leadership qualities to aid them from advancing technology, innovation, and excellence for the benefit of humanity from the speakers all around the world. The prime focus of this summit would be on emerging the cutting-edge technology along with some humanitarian aspects. The major focus will be on areas such as 5G, V2X, IoT, computing, semiconductors, machine learning, artificial intelligence, space, and satellite technologies. We have eminent speakers from NASA, various universities like Tennessee, Curtin, Clemson, Carleton, etc. So, and also we have speakers from various leading companies like Huawei Technologies, Amazon, Cisco, Telephonics, and so on. We also have participant registers for this event around the various regions of IEEE, and we are so happy that we have got reply from many places. And I'm sure the participants will experience the most insightful, thought-provoking, and technically rich summit for these 2 days, along with the workshop what we have. We also have a social media contest for the participants who have registered for this young professional. So the theme is Young Professional as Future Leaders. So the registered participants will be posting their slides on social media, having the hashtag there, and the best one will be awarded during the closing ceremony in the presence of His Highness Sri Yaduvir Krishna the Mysore Maharaja. So why I use the term unique in the summit is all over this, this is being organized by young professionals to the young professionals, and almost all our speakers are all young professionals here. So all the participants, stay tuned, and thank you so much.
Where is Summer? I think he dropped.
Okay, so we can start with the lighting the lamp. So I request the speakers to click on the links being given to you, shared to you before the event. I request Dr. Maike to click on the given link.
I thought I had it ready, so I guess not.
Maike, I have sent you on WhatsApp, so you can just click that link.
Not here.
Yeah. And I request
Ramakrishna, you are also having link. Over mail they have sent. Shall I send you on WhatsApp? I'm sending you. Manjunath, you have done it?
Yes, I just did that.
Yes.
Puneet sir, it's your turn.
I have done already.
Okay.
Yes. So all are glowing now.
Yeah. So we just had this virtually.
Lighting of the lamp.
Experience a real lighting of lamp. So any event started, we usually would like to have a lamp there and have a good new beginning. So over to you, Summmit.
Yeah, thank you all for lighting the lamp. So we would now request Mr. Manjunath Iyer to deliver his special address regarding the summit and regarding YP.
Thank you so much. Thank you, Ashwini. Thank you, Puneet sir, and distinguished guest here, as well as all the participants. I think this is one of a lifetime opportunity, and hopefully this will keep coming every year. It is very unique that Bangalore section has started something like this, bringing in people from various different forums and industries to talk about various different topics. I've been in various different sessions that have been happening in the last 3 days, and some of them were just mind-blowing. I am very hopeful as well as very confident that the YP Global Summit, which is happening now, which we are all here for, is also going to take the Bangalore Technology Conclave to new heights. These are challenging times for us. It would have been really great and insightful if we had been in a physical place to do all of this. But having said that, it brings more people when we are doing this virtually as well. And people have more focus and consume these talks as well as sessions at their own convenience. So that way it has also been a very, I would say, helpful or rather convenient thing for people who are attending from different regions without having to travel. With the leadership of Puneet, Ashwini, and the rest of Bangalore section, as well as the directions from our past chair and regent and director, Ramakrishna sir, I think, there is no stone unturned that the section or the young professionals affinity group has left in making sure that you get the best out of all the sessions that we are going to have. With that, thank you so much. Thank you for having me here. And I look forward to attending more sessions today and tomorrow. Thank you.
Thank you, Mr. Manjunath, for your words. We'll now request Mr. Puneet Kumar Mishra to speak a few words about Bangalore Technology Conclave and about Bangalore section for the non-IEEE members who joined here, and about YPGS in specific.
Thank you, Kumar. Thank you very much for giving the opportunity. First of all, I would like to welcome Maike as well as Dr. Ramakrishna sir on behalf of IEEE Bangalore section, IEEE YP Affinity Group, as well as on my own behalf. Thank you for joining us and providing your blessing. I would consider in inaugural session, valedictory session. We are going to have a show of young professionals by the young audience of this Young Professional Global Summit, which we have conceptualized and conceived in Bangalore section, that we are going to provide a unique platform for young professionals, not only for Bangalore, India, but across globe, where even speakers, attendees, and organizing committee members, each and every one will be from the young professionals fraternity. Only in the inaugural as well as in the valedictory sections we are there, otherwise everything else is managed by these young professionals. So thank you very much. Now formally I would like to welcome you all to the Young Professionals Global Summit 2020, a flagship event of IEEE Bangalore section as well as IEEE Bangalore YP Affinity Group. IEEE Bangalore section is the most vibrant section of IEEE across globe with more than 8,800 members. At present, section is the 5th largest section among 342 sections spread across 10 regions of IEEE. Bangalore section has 2 subsections, namely Mangalore as well as North Karnataka. Very soon we are going to have our 3rd subsection, namely Mysore subsection. With the help of 100+ student branches, 30 society chapters, 4 affinity groups, section organizes more than 1,000 technical events. This was the data last year. And I am very happy to inform that this year we have got this number, and number exists as on September 30th, 1,500+ events section is organized, even this pandemic situation. Bangalore section is also just as outstanding large section in IEEE's Asia Pacific region, which is region 10 for the year 2020. In last 10 months, just to inform our VP, NGA for the next year, that even this pandemic situation, we have opened 14 new student branches, 30 new student branch chapters, 2 society chapters, 1 affinity group, and section alone has conducted more than 150 online webinars. On daily basis, we organize 1 or 2 events online to engage our members during this lockdown as well as pandemic period. Now coming to YP Global Summit. YP Global Summit objective is to bring together young professionals and that to young technology leaders, innovators, entrepreneurs, and thought provokers who are passionate about addressing impactful problems by turning ideas into solutions. Young technology stalwarts and practitioners together will share their vision for future technologies and how they will impact our way of working and living. The aim of this summit is to know future of the technology from the young professionals' perspective, research areas from young industry leaders as well as young experts. Second objective is to create a learning ecosystem from young industry practitioners across the globe who have succeeded in creating inclusive learning environments. The prime focus of this summit is on emerging and cutting-edge technologies along with some humanitarian aspects, because IEEE is known for IEEE Tech Sciences technology for humanity. So we very consciously take care that each and every event, summit, or workshop, what we organize, we also include humanitarian aspect in that. The major focus will be on areas of 5G, V2X, IoT, computing, semiconductors, machine learning, artificial intelligence, space and satellite technologies. 20 plus distinguished speakers from India, USA, Europe, South Asian countries are attending this YP Global Summit 2020 and will be providing their valuable insight to the delegates. We have registered delegates for this summit from Australia, Japan, China, Malaysia, Thailand, Hong Kong, Philippines, Taiwan, Bangladesh, Nepal, Sri Lanka, as well as Pakistan, UAE, Canada, USA, Argentina, New Zealand, and other countries in addition to India. We sincerely acknowledge the YP Organizing Committee for their tireless effort in bringing together an array of internationally recognized speakers in the related fields and making this summit a big success. Maike, I want to inform you this YP Global Summit is fourth event of our mega industry focused event that is called Bangalore Technology Conclave, in which first 2 days we organized an industry focused event mainly focusing on artificial intelligence. Third day we organized Women in Engineering Global Summit, which was focused on women in artificial intelligence and women in leadership role. Today morning we had a very focused workshop on defense and space technology, and this remaining 1.5 days, means today evening and tomorrow entire day, we are going to have this whole YP Global Summit. With this, again, I would like to welcome each one of you from the deep of my heart for joining us and encouraging us in this inaugural edition of Young Professionals Global Summit. Thank you very much.
Thank you, Puneet, sir, for welcoming the audience and giving your thoughts and your inputs on what BTC is and what YP Global Summit is. So next we would have special address by Dr. Ramakrishna Kapagantu. Dr. Ramakrishna is currently VC membership at MGA board, and he was the past director of IEEE Region 10. He has served on various IEEE boards until now, and he has also won many awards from IEEE, which include MGA Larry K. Wilson Transnational Award and MGA Innovation Award, which are few. And we are very delighted to have you, sir, at Young Professionals Global Summit. The stage is all yours.
Thank you, Samar, and greetings to all of you, dear friends. It's a very good opportunity, in fact, for me to join the young professionals, because student members and young professionals are my favorite categories in IEEE, right from my starting of membership 30 years ago. And I've been fascinated by the student activities and young professional activities. And in fact, I encouraged, and if I remember in 2009 or 2008, when I was the section chair, we reopened the Gold Group, the erstwhile YP. It's called, Gold is graduates of last decade. And Gautam from Microsoft, he was the chair inducted, and his colleague from another guy, they are YP chair and vice chairs. During 2009 itself, we did a global summit of a Gold Congress, that is called, 10 years ago. And I have seen there's a lot of potential among the YP members, especially in the section of Bangalore. And I really congratulate the young professional team as well as the Bangalore section leadership. They put a lot of efforts and they brought a lot of flavor to I can say, to engage or activate the YP members in all ways and in all walks of the life, especially during this pandemic. This pandemic has created a lot of trouble for all of us. It has hit very hard on our basic face-to-face interactions, because IEEE is meant for networking, and with that can be proved only through a face-to-face interaction, and which we are lacking today. And on this virtual platforms, however, IEEE has been providing good opportunities And I think this pandemic challenge definitely we should turn into opportunities. And during this virtual engagement, I has done a great job, and she's encouraging all the YP chairs of affinity groups of all the sections across the globe, and they did a lot of activities. And every region, Region 7 young professionals team have focused their efforts on increasing collaborations with technical societies and becoming involved with global events and virtual technical conferences. And Region 8, the virtual student and young professional Congress attracted 1,800 registrations and took place over 13 days, I believe. And they also played a key role in the Congress organization, the YP team, and hosted several sessions and first entrepreneurship competition. And Region 8, they had a very good event of, for transitioning the young professionals through their connected experts, I think. So this has been expanded to all across the Region 8, to include speakers from other regions as well. And it has been promoted to YPs across the world. Webinars were organized, and it attracted more than 17,000 participants. It's connecting experts by Region 8. And Region 9, nevertheless, the team helped to organize Heart Tech COVID-19 Hackathon, which attracted again 1,000 participants. Okay, and Region 10, the Student, Young Professionals, Women Engineering and Life Members Congress. Again, it attracted 1,000 attendees and more. And it also went over a week. And I can tell you that apart from these, Bangalore section has a special potential. It can definitely compete with any regional level YP activities. That much potential they're having, and I know the leadership and the encouragement from the section, what they achieve, it is tremendous. And with this, I think the young members, the young professionals, they should be a mentor for the student branches, and they can learn a lot from the life members, and they can play a key role among the high-grade members. And that's why the young professionals play a pivotal role in all these activities. And I feel the membership, though it is a low as per the September statistics, I think 6.3% is lower than year over year of YPs, but it is much better than students, which is a 10% loss is there. And I think they can make a lot of efforts to connecting with the young professionals through virtual platforms. And I think the volunteering platform that is being provided by the YPs, the new initiative, it is an improvement of the micro-volunteering. And the volunteering platform is the continuation of this micro-volunteer project. And which it is a part of the YP business plan for 2017 to 19, and it's been getting extended now, and it has taken a very good shape. The platforms of the volunteering platform of YP, the main goals are like it will simplify the processes of starting to volunteer, how to do that right from the micro volunteering level and all, and provide flexible volunteering opportunities that are project and skill oriented. And it will overcome geographic boundaries, encourage long distance volunteering, especially during this pandemic, and it will enable a recommendation and a feedback process to recognize volunteering efforts regardless duration or intensity. And definitely it would encourage merit-based advancement on the IEEE career path. And I think, they're also doing good things across appointing ambassadors of YPs across the globe. And they're looking for ambassadors from several places. And I know we played a key role in Region 10 as well as in India and Bangalore. And I know that Region 10 award for YPs has been received by our own Bangalore section guys. And I congratulate, and they have done an excellent job. And more about YPs, definitely, I think Maike, the incoming Vice President for 2021, she will be giving a presentation on YPs, and it will be a great initiative for us to get aware of really what are the opportunities and what YPs can do. And I strongly believe that YPs are the future leaders, future owners of IEEE. And you should come together, make great efforts, and feel that IEEE is the only platform that can connect the world for all the needs of the society. So such workshops, such global congresses, it would certainly help one and all, to recognize the importance of YPs. And I think it will play a key role. And I wish all the best the young professionals of Bangalore section, and I congratulate them for taking the lead role on this, and especially Puneet Mishra and Dr. Appaji. They are really doing wonderful things, and I wish you all the best. And I thank you for giving me this opportunity to share a few of my thoughts on YP, because it is very important. In fact, in all the boards across, it is made necessary, it is mandated that at least one YP member is there on the majority of the committees and board level things, So people will learn, and they can understand the role and need, and they can rise to the occasion. Thank you very much, Saman and Puneet.
Thank you so much, sir, for your encouraging words. We definitely take best practices that you mentioned, and for the coming year, and YP Bangalore, a very vibrant one. Next, we will have we'll have our chief guest delivering the keynote. Our chief guest for today is Dr. Maike. She has completed her PhD, and she is a senior member of IEEE, member of IEEE HKN, and is currently the 2020 IEEE Vice President-elect of the MGA. She served as President IEEE Canada 2018-19 and Chair Policy Track IEEE Internet Initiative 2018. Currently, she is the Adjunct Research Professor at Western University. She was the founding director of the Blue Water Technology Access Center, following 8 years as Dean at Lambton College, with a number of portfolios in technology, business development, sustainable development, and applied research. Her strategic leadership in developing the applied research and innovation capacity and portfolio led to Lambton becoming a top research college in Canada. Her areas of interest and expertise span diverse technical areas as well as policy associated with their implementation. She has particular interest in how progress in one area, example ICT, enables advances in other disciplines, and in how deployment of various technology contributes or not to achieving sustainable development. She has experience in the public and private sectors in Canada, USA, and Germany, and is involved with a Canadian startup company. Welcome, ma'am. The stage is all yours for your address.
Thank you very much. It's a great pleasure to be with you today, and I'd like to share my congratulations with all of you as organizers and participants on this wonderful event. So I'm bringing you greetings on behalf of MGA. So you have two greetings from Ramakrishna and myself to this inaugural event. And yes, I firmly believe that young professionals are the future of IEEE. A couple of words about myself to add to this wonderful introduction. I've changed the picture. They are now COVID pictures. So you see a picture in front of ice clothes. That was from my trip to Bali to the Region 10 Congress a couple of years ago, the YP Congress a couple of years ago, flying over the Canadian North. So this is a Zoom picture. So I figured, seeing as we are all working on Zoom or WebEx or Google Meet and so on, I would show that. So we already alluded to humanitarian activities. Personally, I came to sustainable development quite a few years ago, and I actually came up with a couple of taglines, and I firmly believe these are true, and that IEEE provides the best opportunity to actually work in this direction. And I think if we are talking about interaction, and this summit is one kind of interaction, as being the catalyst of innovation, IEEE enables us to have this interaction and to catalyze innovation. If we talk about the benefit to humanity, education is a catalyst for sustainability. And IEEE gives us that vehicle, that framework to catalyze education, use education as a catalyst for sustainability, for humanitarian efforts. So where do I live and work? I live in southern Ontario, that's very close to the border of the United States. This is where the oil industry started in North America, about 30 kilometers from here, and also where huge leaps were made for renewable energy. You see the solar panels in one of the images. At that time, when those panels were up, this solar farm of 60 or 80 megawatts was the world's largest solar farm. It was that for a couple of years. It's also a lovely area, as you can see from the other pictures, for recreation. So when I was working at the college, I was working in renewable energy and essentially instrumentation, as well as working with the oil industry and chemical industry. Let's go to IEEE. We already heard a few numbers about young professionals, but have a look at the size and the reach of IEEE. At the end of 2019, there were about 420,000 members worldwide in 160 countries, organized in 46 technical societies and councils, and of course other verticals as well, like human and humanitarian activities and future directions. Of this membership, about 125,000 students and close to 100,000 young professionals. So if you look at the membership, as Ramakrishna was alluding to, there's about a third of them are students, about a quarter are young professionals, and then we have the higher grade members. And this emphasizes the importance of the young professionals within the association. So who are those young professionals? Who are you and we, right? So amongst the young professionals, we count all the active IEEE members who have graduated from their first university or college degree within the last 15 years. So that doesn't matter whether your first degree was finished when you were 21 or 22 or 35. And within IEEE, the young professional status or the young professional group, affinity group, is free to join. It is not a membership grade. It's a statement of engagement. So truly, within the young professional affinity group, you would find graduate students to senior members. You will probably find life members. Actually, I'm sure you'll find life members within the young professional affinity group. And those are the people who believe that young professionals are essential to IEEE. And the last statistics here that I have are 96,000 members worldwide and IEEE-wide. I think there was a number from sometime within this year. So it is a big force within IEEE. Excuse me. So what do young professionals really want? What do they care about? Within IEEE, of course, they would like to have, and they should have, a key role. And that is being established with membership of young professionals on most committees and in most sections around the world. So there is a role of young professional representative on section executives and so on. Personally, what a young professional would like to do is to grow a professional network and stay technically current. That is on the professional side. On the engagement side, they're looking for meaningful, flexible volunteerism that will at the same time advance their leadership skills and experience. In other words, as a young professional, and this probably applies to most volunteers across the organization, is the activity that you engage in is something that you believe in, that means something to you, a goal that is worthwhile to achieve, while at the same time giving you new skills that are hopefully also going to provide some advantage to your career. So furthermore, young professionals do like to see their achievements recognized. For that, we usually use awards. The activity and engagement in IEEE should enhance their career opportunities. And as I said before, young professionals especially like to volunteer for the greater good, to improve global conditions. A mentor of mine years ago pointed out that you should volunteer on your professional side and on your private side, in your private life. So, for example, you volunteer with children, in your children's activities. You also volunteer on the professional side because you should share your volunteer time, hour, and engagement such that one side addresses your needs to make the world a better place, like improve global conditions. One activity looks after your career advancement or helps you in your career advancement. And if you can make the two come together, and IEEE gives us that opportunity, then your volunteering helps you to achieve your global goals and helps you to advance your career, gain skills that will help you advance your career. So where are the young professionals in the world? We have in the order of 40,000 in the Americas and 50 to 60,000 across Europe and Asia Pacific. And they're really everywhere. Of course they're everywhere because they are hired by the young companies, they're hired by established companies, they work in government, they teach at universities, they engage in organizations in IEEE and in others. So what do young professionals do as the young professional organization within IEEE? We really split this into three activities. One is to support the volunteers, because in order to engage the members, we need the volunteers to talk to the members, to arrange events for the members, to interact with the members and help the members with their careers and career advancement and their networking. And of course, we promote by these young professionals in IEEE to give them a bigger voice. So this is translated into some funding for events and support, and there's some up to $750 for local activity funding. That also applies to virtual events. There's funding for meetups. There's the funding for the STEP program, which is the Student Transition and Elevation Program, and of course, training resources. I believe the STEP program is a really interesting program because it links the students to the young professionals and brings together two groups within IEEE to work together with one mentoring the other. And it has been a huge success over the years. It was started when young professionals were still called the graduates of the last decade. To engage the members, we need to support and do support IEEE volunteering. IEEE volunteering, especially young professional volunteering. We have special events like the one today and tomorrow. And of course, we have young professional sessions at conferences and other events and provide much access to interaction and educational materials. Within IEEE, as I mentioned, it's a system or systemic effort to have the young professionals present in the different organizational units and geo units, and on the other hand, reward achievement through an awards and recognition program. So the young professionals in IEEE is then expressed in, as I said, having financial support for the young professionals by IEEE, within IEEE, appoint young professionals to leadership roles on committees, in sections, and so on. There's staff support. There's research funding to understand better the needs of this, of us. And of course, an award program to recognize achievements, in particular the IEEE level Theodore W. Fitty Outstanding Young Professional Award. And what have we accomplished? Thousands of members engaged in local activities. There has been a lot of support during this pandemic with instructional and team building and career building webinars. We have opened an IEEE Young Professionals Hall of Fame, awards to society. Young professionals have done a fantastic job of maintaining contacts with all the members through social media channels, newsletters, and so on. And this year came to fruition, as Ramakrishna already mentioned, the building of the IEEE volunteering platform, which is now released in its initial release. A few more words on the volunteering platform. We call it volunteering on your terms. And the key difference between volunteering with IEEE until this volunteering platform came to be was that most of the volunteering in IEEE is by role. Volunteers take on a 1 year, 2 year position and volunteer in that role. Other than conferences and event organization is a role for a particular event. What we learned from the input of young professionals is that young professionals like to volunteer in a flexible manner that essentially allows to volunteer in chunks on a particular topic and so on. So the volunteering platform is laid out to permit that, to enable that, and to foster volunteering in a very flexible way. It is laid out to automatically generate essentially a volunteering CV It is laid out to be able to recruit volunteers across IEEE. So somebody from Bangalore may volunteer for an event in Joburg, in Johannesburg, in South Africa, for example. And what happens now? There we go. So I mentioned already, it's a cross-IEEE platform. The platform is there at volunteer.IEEE.org. It is a platform that is essentially a dating platform between units or people who specify what will be volunteering opportunities and volunteers offering their services, their volunteering goals, and essentially links up these two sides of the volunteering spectrum. And once a volunteer volunteers, confirms his activity for his or her effort towards a particular role, agrees to carry it out, a role or a particular activity. Once it is completed, it is recorded in the volunteer CV, so to speak. And so this should help us track the efforts that all the volunteers are putting forward and to recognize it appropriately. So it is not the role that gets recognized, it is the effort and impact that is recognized. So start using the IEEE Volunteering Platform. And this brings me close to the conclusion of my presentation. I'd like you to remember that at IEEE, what we are known for and what we are trying to do always is take the something is happening with my presentation. Take the I am out of the word impossible. We are taking impossible and making it possible. In IEEE is about inspiring, engaging, encouraging, and empowering. It's our future, it's our mission. IEEE fosters technological innovation and excellence for the benefit of humanity. Together we can and we will make this world a better place. Thank you.
Thank you so much, Maike, and IEEE Volunteering Platform from an MGA perspective. Thank you so much, ma'am, once again.
Samarth, I am having one question for Maike.
Yeah, go ahead.
Yeah. So, Maike, till now for young professionals funding, if you see, there are meetups funding or event funding. So $750 and $1,500. But as a section now, when we are trying to conceptualize this kind of big event in the name of YP Global Summit, so I request as a MGA VP next year, please see that this kind of event, especially global summits, which we are trying to organize, should be funded in a slightly better manner rather than only maximum cap of $1,500, so that we can really organize in a grand way.
So it is actually the Young Professionals Organization that determines how their funds are spent. So that request will need to be taken to the Young Professionals Chair and the Young Professionals Committee. So I would suggest that this would be taken to Flavia to discuss within the Young Professionals Committee. And I would also suggest that if you have large events that you would also approach societies that would be linked to this event and who would support such an event.
Okay, thank you. Thank you. Thank you very much. We understood your point.
Thank you, ma'am. So we come to the end of the session. Would like to request Neha to propose the vote of thanks, after which we will be sharing a token of appreciation to our chief guest and guest of honor.
Thank you so much. So, Honorable Chief Guest, Dr. Maike, Dr. Ramakrishnan, Manjunath sir, Chair Puneet sir, and Dr. Ashwinin. It's my privilege to be having asked to propose a vote of thanks for the very first edition of Young Professional Global Summit 2020. On behalf of IEEE Young Professional Bangalore Section, IEEE Bangalore Section, Partner Bangalore Technology Conclave, and the entire YPGS, I extend a very hearty vote of thanks to the guests for gracing with their presence and kind words. I would begin by thanking the NI students for the innovative creation of lighting of lamp. It was done beautifully. I would like to thank our guests, Dr. Maike, Dr. Ramakrishnan, Dr. Manjunath sir, for their presence and for resonating that YPs are truly the future of IEEE leaders. Your words were encouraging, inspiring, and it was an honor to have you amongst us. Next, I would like to thank the conceiver, the foundation of YPGS, Puneet sir. Sir, your guidance, without your guidance, YPGS couldn't have been possible. You have always inspired the entire Bangalore section YPs to be young and energetic as you embody it. Your thoughts about the path to cutting-edge technology, path to humanity, has definitely instilled new thoughts in the young minds. Last, but definitely not the least, I would like to thank Dr. Ashwini Appaji, the pillar of YPGS. Your bird's eye view to every requirement and details, your generous and compassion towards each YP member to be involved in this conference made this event possible. An event like this cannot happen overnight. The wheels started rolling months back. We were fortunate to be backed by a wonderful team, be it the organizing committee, design team, publicity team, and many other volunteers, if I may say so. Their dedication, their tireless effort has brought YPGS 2020 to life. I would like to conclude by saying, attract what you expect, reflect what you desire, become what you respect, mirror what you admire. I'd like to thank each and every one of you once again for being a part of this and giving your presence. And I now request all the panelists to please switch on your cameras for a virtual photograph. Thank you. Samat, could you help us with that?
Yeah, sure. We'll click a photograph. And Puneet sir, could you pass the presentation by me so that I can present the screen later.
I request everyone to please turn on your cameras.
Thank you, everyone. So before we end the session, we would like to present a token of appreciation to our guests. Is my screen visible?
Thank you very much. The best of success to you all.
Thank you, Ma, for joining us today.
Luiken.
Thank you, Maike. Thank you, Dr. Ramakrishna sir, for joining us.
Thank you very much. Thank you, Ashwini and Maike. See you all.
Well, thank you.
Manjunath.
Thank you, Mr. Manjunath, for joining us today.
Thank you, my pleasure.
Thank you very much, Puneet sir, for being the pillar of support for all of us and being there always. We will be having our first session for the day. Request Neha to take over from here.
Thank you, Kumar.
All the very best.
Thank you, sir. Thank you. So our first speaker for today is a young and dynamic mind. He is Naveen Mamgian. He is the co-founder and design head at QuickRide. With techie, design digital first thought process, he scaled QuickRide rapidly in the last 5 years. He loves to work with startups, mentor them, and learn from them. He's a strong advocate of user-centric designs and focus on processes. Previously, he has worked with Railiatri, Happiest Minds, and CenturyLink. Some of his other interests include psychology, fitness, and cooking. Thank you, Naveen, for being a part of this conference. Over to you.
Thank you, Neha. Thank you for the warm welcome, and thanks for inviting me for this esteemed conference. I really thanks to Ashwini ma'am and you to introduce me and to give us the chance to share what we have done and what we think about it. Like, when you give me this, give me the title of this conference, which is Young Professional Entrepreneur, it's really exciting. Like, as a young, I don't know if it's young or not, but what we have learned so far and what still we are learning, it's really unique. And I really want this to share with you all and see what we have done, or if anyone can take some insights from this, from our journey, it would be really great. And definitely it will be very, interesting experience for us also, like especially for the Indian market. So let me share. I hope it's all can see that. So young professional as entrepreneur. So first of all, I just want to tell about our organization, QuickRide, and we want to create the community and especially the culture where every commuter can share the seats. And the medium can be anything. It can be car, bike, or in future other as well. So we want to enable everyone to use the technology so they can discover, they can connect in a real-time manner. So when we started this, we know that that time people were saying, hey, why you guys are starting carpooling thing? Everybody knows about it and it doesn't work in India. And a lot of people have already tried. And it is the fact that, people have tried it. Even Indian player, even the international player also came to India, and then recently, everyone has wound it up. But why we have succeeded? Because of our, I can say, our values and the core problem what we solved so far. So that's what about us. Right now we are 4 million plus users. We have done more than 30 million carpools and share 200 plus million plus kilometers shared. We have a presence in 9 cities, and total we have reduced 92k plus ton parcel. So to start with, like, I want to tell you how many founders are there. So KNM Rao is there, me, Shobna and Vishal. So I'll tell you from my perspective what a young professional as an entrepreneur can do. And then they start their own thing. So I have divided my things into 3 main sections. As a company, what you can, consider as an individual, or as on the product side. So these are the 3 categories which is very important for a startup. So when we start with a company, so first, definitely it's a, if you search over the internet also, you will get a lot of articles, okay, when you start with the company or when you start with the product, do research. But research, what kind of research you do, that's very important. Like I'll tell you from our example, when we started this carpooling thing, so that time research was not about that, product is available in the Indian market or not, or how many people are using, such kind of solution, which was carpool that time. How many people are using that? The research was what people think about this, why this thing is not working. Because from the core of our heart, we knew that this thing is need of the hour. Everyone knows, there's a lot of traffic and people are going in the same direction. But so carpooling, it looks very simple. So why it's not working? So then we have done the research, and that research was not limited to only product and technology. It's about the culture as well. Why people think before sharing their commute with others. So the research is very important. That makes your product one step ahead. It's not like that what you want to build, it's already there in the market. But might be that product, that organization didn't research that properly with your market segment. What we research the professionals, daily they are going office to home, home to office, but why they are not doing carpooling. So then we came to know, okay, first is the cultural issue. Second is the technology, the real-time technology. Third is the payment thing. People don't want to, talk about the fare, and especially when you are a professional and you have to pay to another, it doesn't look nice. It's a very weird thing. So those kind of research we have done on the ground, and then we launched it. Second, positive take rate. Positive take rate is, it's a business. Like, if you have started something, if it is a NGO, it's fine, but if it is a business, it has to give you positive thing. Like, you should earn out of it. It should not be you're just burning. So your model should be earning specific. Then only you can sustain your startup for a longer time. And if you sustain your startup for a longer time, eventually you'll become successful. So positive take rate is very important. In our case, what we have done from the very first ride, first month, we have done only 42 rides. First month. And after 5 years, we were doing close to 1,02,000 rides. So, but for that journey, from the very first ride, we were taking the commission. Like, that's the business. We, from every ride, we were charging 6% commission. That is very low, but still it's the earning to sustain our model. So that is very important from the company side, from the business side. Third thing, being frugal. It's our one of the core principles, being frugal in everything. Everything means, like, if you're using any platform, if you're using any marketing medium, if you're using any campaigns, you have to be frugal. Because if you know how to be frugal, definitely you'll sustain for a longer time. And all the money you have, you can sustain it. And especially this principle is very much helpful for us nowadays, because we have saved to sustain for this period of time. Like in the current pandemic, rights are not happening that much, but we have that funds to sustain our business. And it should not only limit it to one category. Like, it should not limit it to infrastructure cost. It should not limit it to marketing campaign. It should be applied to each and every vertical, even it is hiring, even it is various incentive schemes to the user. You have to be frugal, very frugal. Being a startup, if you start something, you have to be very frugal in that. Fourth thing, definitely is persistence, because it's a tough game. Like if you choose a vertical which is very challenged, people have already given up for that idea. So you have to be persistent, because if you are persistent, you will see lot of ways. Like persistent, though it's a very simple word to say, persistent, but in application, it's like when we started, everybody say it's carpool, okay, definitely, but nobody's in my route and I don't see a lot of people. So then we thought of what we can do. So we persist for some time, and then we get the idea, okay, why don't we go for the B2B route? Like we go to the companies, we tie up with them, and then we campaign over there. So if we get the supply and demand from the same location, might be rights will happen. And if the rights starts happening, people have the confidence, okay, this thing is working, carpool works. So persistence is very important. So this everything is aligned. Like if you have done the good research, it's good. Then if you have that business should be positive and you should earn something out of it, it's very important. And whatever you have earned, you have to spend very wisely. So in that, persistence is very much required. So from the company per se, these four things, it's our advice. Like I had a discussion with KNM also today morning. Like we have the session with IEEE. What's your thought about it? So he also contributed in this one. He especially said being frugal is very important. Positive take rate is very important, because if it is a business, you have to sustain it. Once we move it to the individual one, like as an individual, now like it's my learning from the startup quick ride. As an individual, you have the role of entrepreneur, what you can do and what you have to do to be successful in your startup. Like wear many hats. It's not like you have to wear many hats in different roles, but you should know end to end for every technology, for every domain. Like in our case, if I tell you, Shobna, she is the co-founder of Quick Ride, and she set up the entire architecture of Quick Ride, full hands-on. She takes care of the server side thing also. Then the Vishal, everyone has to wear many hats. It's not limited to their core domain. It goes beyond their domain, and not from the high level, from the ground level. Like in our side, we should know how to do the campaign. Like we go to the companies, we know how to set up the campaign, where to go. It might be cafeteria, parking area, or at what point in the company premises. So how to carry out the campaigns, at what time, what campaign you have to launch. If you are launching one campaign, a lot of things are required. If it is a video campaign, you have to you have to get your videos done. So how to work with the agencies, how much money you have to put on that stage, then how much ROI you are getting out of it, how to publicize that video, how many video cuts. These are very small things, but as a individual, you should know and you should handle all those things. Then those frugality, like how to save from the each step, you will understand. So that's very important. As like from my side, I take care of the entire Quick Ride digital presence, like the application on all the platform, our progressive web app, our marketing, our print. And when we say handle means we do all those things, like hands-on. We create, we design, we discuss, and then ship it to the development. Then I work with the development team, okay, how it, from the UI testing and all, and then calculate the ROI. So it's very important for, to start your, to start your startup, it's very important how to play the multiple roles. So if you're playing the multiple roles, definitely you have, you'll see the, compromise on your efficiency. So that, there you have to play the, the major role, how to work on your efficiency. What is your core area? If your core area is something, let's suppose in my case, it's a design. So if I create the user experience for the entire application or for a flow in 5 days, so how to improve on that efficiency? I have to see on the time limit, like what is my timetable? If it is in 5 hours, I am delivering this much. After a week, after 2 weeks, what is the progress on that? So for that you have to, record each and every task of yours and translate it into hours. Then on every week you see how much hours you have given for that particular item. So after a month you will get to know, okay, this much of hours I am putting on this entire subject. How can I improve? And to improve that, we have to create the process. So that process is not, which is general process, it's your own process. Like if you have to design something on a particular level, let us suppose you have to design a feature for the mobile app. So you will define that process for yourself. What is the template for it? So the template is, okay, I'll do the user research. What is that user research? I'll talk to these 3 users. That's the only in your process. Then I'll do the comparative study, which is there. After that, I create the one wireframe, and after that, I test this user and create the visual design, ship it to the developers. For that, you create your own process, what works and what didn't work. Because you have to work on very tight deadlines. Because as a startup, there are tons of features you want to give it to your users. So for that, how to work on your efficiency, so to get the more efficient in efficient manner, you have to create your own processes, and over the period of time you will refine. One sec, I got some chat. Okay, that I'll take it later. So that's the from the individual side. Wear many hats. Wear many hats means it doesn't mean you have to just oversee the domains. You should know each and everything from that domain. Work on your efficiency, how much time you are giving on each task on different domains. Calculate that hours and then see how to optimize. For that, you will create the process. If you have the process that goes in your template thing, every time that work comes, you will follow the template and the things will get done. That's very important from the individual side. From the product, what we have learned so far from our carpooling thing, first is build the trust. Trust means, definitely trust means people should trust your product, but how to build that? For research also plays a major role, but you have to see many ways. Like in our case, when we launch Carpool, then first thing we get to know from our user research, a lot of people say, hey, I tried and I have, submitted my route details also, but nobody there in my area. Like I don't get any ride. And it happens, like if you start some product, definitely not a lot of people are there. In our case, it's very important because if people are not there, carpooling will not happen. So for that, what we have done, we have created a very simple feature. Like if you log in, you will see how many people are around you who use this application. So for that, people gain that trust. Okay, users are there. They might not going at the same time, but users are there. So they will try after 1 day or after 2 days or after 3 days. But initially, if they're seeing people are there, that builds the trust. So like that, there are a lot of things from the product, from the support, from the communication. So the trust is very important. If they believe in your product, they'll come back even a day, 2 days, 3 days, even after a week. That is very important. So the second thing is pricing. It's a very tricky thing. What is the pricing? So pricing, it's a perceived value of your product. People like we have also learned that, you know, people say pricing should be high because if it is high, people value you more. But if it is high, people won't pay for it. So that's a very tricky part. So, but pricing is the role which you have to consider when you launch the product, and just see how to define that. In our case, we already thought of it. Okay, our pricing should be this % of commission, and it has to be constant. It has to be constant. Then the organic growth. How your product grows, how your startup grows. Definitely, there are a lot of methods, but what we believe in organic. Organic means users. How users drive their product. Like, it's a very interesting fact from the Quick Ride. It's in Bangalore. It's the way we have achieved our scale. Our users play a very, very important role in it. They are our, you know, advisor. They are our, you know, supporters throughout this journey. They refer a lot of people. They believed in that idea, and then that's how our community builds. So for that, after some point of time, we thought, okay, why don't we create a incentive kind of thing? So which is already there. But the difference is incentivize your top users. They are your assets. They are partner in your startup. So if you incentivize doesn't mean only in terms of, you know, money, cashback and all. It can be anything. It can be a very good gesture or anything. Like nowadays there are a lot of examples for that. But incentivize your top users, your early users who were part of your journey. So they will take you from one level to another. So the last one is the digital presence. It's like we have also learned in the past how to take the leverage of digital platforms. But digital, like, it's a far experience. You know, there are a lot of companies, they have different experience for that. But from our side, digital always, it comes with a cost. But there are still a lot of activities you can do digitally, which gives you very, very good engagement and growth rate. Like, it's not always about you do the Facebook ads, that to app installs, or the local ads on the Google side, or use a lot of tracking tools. There are a lot of free things are available. How to integrate it, and how to take the positive out of it. You know, for that you have to learn a bit, but it's very easy. Anyone can handle it. Like, it's very easy for a startup to create few pages on all the social media, then create a few templates for their communication, regularly set the template, send the communication to the users, and bring your page alive. And it gives the user constant engagement about your product as well. So digital presence, don't take it very lightly. It's very important, especially all the platforms, whether it is SEO or the, or other channels. So that content is very important. And digital doesn't mean you have to put a lot of money in it. You can do without that as well. That's the three part which I wanted to share with you. Come as a company, as an individual, and from the product side. Last, for me, like, what I really believe is your company DNA. Like, it's not easy and it's not that simple. Like, our DNA is hardworking and our DNA is very agile. It's not that. It's like, identify what you are good at it as a startup, as a team, like how your vision aligns. Like, if you are persistent, that is your DNA. You are persistent in your effort. You believed in your idea and you started this, and now you are persistent with your efforts. So identify your DNA. It's very important to grow your team size also. Like when you hire your co-founders, your key players, the DNA matters. So it's not the mandatory step, but while starting your startup, it's very important if you can think of your DNA, then align your vision and mission with others, and definitely it will work for you. Thanks. Thank you so much for the chance to share our insights with you. And I'm Mamgian from QuickRide, and I'm happy to take any questions, whatever you guys have.
So Naveen, we questions.
Okay.
But one question I would rather want to ask is, what is your perspective? If I have to, in this pandemic, how things have changed. How you're looking forward to, after this pandemic. Now, what is the situation, and post pandemic? Do you think things will change?
Like things have changed, and especially for the community segment. It's not like it's not earlier. People have changed a lot. Like companies have changed their policies. It's not work from home is a new normal. So for that, we also thought of like commute helped us to build that community. Now, how we can help that community in different vertical segments? So that's why we have launched our 2 verticals. One is the normal taxi options, which is way more cheaper than our competitors. Second is our job platform, and there are one more is on the way. So commuting segments have changed, but as a startup, you always think of what you have built so far. So we have built our community. So for that community, how we can help, that's our agenda right now. And to consider this, we have already launched 2 verticals.
That's a very fair point that you have made.
Yeah, one sec. Actually, someone has asked.
I have a question, Naveen.
Yeah, please speak.
How was the job being targeted in QuickRide? Did people really lose the job, or did they? The salary got cut or something like that. How was this generally in QuickRide? What has happened?
The job platform we have launched.
Yes, overall, the question was overall, how have we, jobs being affected, pay scales being affected by the QuickRide? Has it been affected, or just remains the same?
It's affected us also. It's not like that, we are untouched. It touched to us. We also optimize, like I said, we are very frugal, so that frugality we have applied to ourselves also for some period. And that's how we, in optimizing in all the cases, like infrastructure side we have optimized, from the talent side we have optimized, from our growth side we have optimized few things. So
okay. So we have another question. You share some insight to design. You touched, where you're mentioning about individual standpoint. So what do you mean by, it only includes how it works exactly. Somebody wants to know.
Yeah. So the question is, can you share some insights on design as you touched this? You are mentioning about the individual. So design, like I say, definitely it's not like how it looks. Of course, it's how it works. But if as an individual, if you are taking care of the design, it's not only one part of it. Like if you are a designer, you are a UX designer. So if you are a UX designer, you should not limit yourself to a UX, because when you go to the different vertical, which is the print and or the digital side, you'll learn a lot. You learn a lot, and then you say how to make your print learning in your digital. Like in this case, I'm a UX designer, but when I go for the campaign, then I came to know how users think about our sign-up flow. So for that sign-up flow, we'll definitely get all the learnings in our application as a UX designer. At the same time, in our print communication, we also say it's a 3-minute journey. So that's what I'm saying. It's from the individual standpoint, it's not only one thing, which is the UX design. It has to be a print, your campaign, because other things also gives you a lot of learning that you can directly apply on your own vertical.
Okay.
So,
so we'll take one last question. We will take that. So could you please share how to get into entrepreneurship, early in your career, and how did you go about it?
Like, okay, I'll tell you my journey. I worked with like KNM. KNM contacted me and said about this idea. Like, what do you think about it, and can you help us in this thing? And then we discussed a lot. We always do early morning meetings to discuss about this idea. And then I am very much convinced. I said, definitely, I'll be a part of it. And that's how it started. Like for this one, you have to completely sold out with the idea. Then only you think, okay, yeah, I can do it. I should be a part of it, and I'll do whatever I can. It's not, this is my strength, definitely, that I'll definitely bring on the table. But what else I can bring, that's what it matters in your entrepreneurship journey. And how early in my career? I think 5 years back I started.
Thank you, Naveen. In the interest of time, we would conclude your session here. And thank you so much for sharing such wonderful insights on the product, how to go about it, bringing your raw startup perspective. Thank you so much, and please practice enough appreciation from us.
Thank you.
Global Summit. Thank you.
Thank you.
Over to you, Samar.
So Naveen from Ashwinin here. So it's like really nice that you are with us today, because me being a user of Quick Ride, and I just used to think okay, let me go for a ride. So I never thought that I would even get an opportunity with I would get a time, spend some time with you.
Oh, it's my pleasure.
So it's really nice for accepting our invitation and being a part of this. And thank you so much for being here.
Thank you.
So can we go? Anis, can you hear us?
Yes, I can. Can you hear me?
Yeah.
Great. So, yes.
Hello. Yeah. One second. Yeah, I'll introduce Dr. Anis Ben Arfi to you all. Dr. Anis Ben Arfi received his PhD from Calgary in 2019. He currently works at Analog Devices in Ottawa, where he focuses on 5G wireless systems and signal processing algorithms. Anis has been involved in the Rising Star Conference since 2016. He formed as passion monitoring with the conference team and served as 2020 IEEE Rising Stars General Chair. From 2014 to 2018, Arfi has been part of IEEE Southern Alberta section and has been instrumental in organizing events, initiatives, and events. Currently, he volunteers for IEEE Ottawa section, chairs the IEEE Canada Humanitarian Initiatives Committee and IEEE MTTS. Over the course of his studies, Anis has participated in several national and international events and conferences and many prestigious awards. Now, over to you, Anis.
Thank you very much. If you can give me the hand to share my screen. All right. Let's see. Let's do screen 2. Okay. And let's try this. Can you see my slides?
Yeah, it's visible, Anis.
Great. So first of all, thank you very much for the invitation. I'm truly humbled. This is my second time in Bangalore. The first time was in person, and due to the circumstances this year, I had to come virtually to talk to you. So my name is Arfi. I'm a volunteer of IEEE based in Ottawa, Canada currently. Before that, I was in Calgary. So I will talk to you about my journey, because when I was approached by Ashwinin and her team, I was thinking whether I go purely technical stuff, which is my PhD work and all the RF signal processing, transceiver design, whatever. Then I thought, no, I'll do it in a more fun way, talk about my IEEE involvement, and I'll focus more on technical activities and also humanitarian activities as well. So a bit about myself. I'm Tunisian originally, moved to Calgary for PhD and master's and PhD. And now I currently work in Ottawa after I graduated. I did a 1-year postdoc, then I got a full-time job with analog devices. So this is IEEE Canada. I know Maike was talking about IEEE Canada. She's the past president. So I first started volunteering in Southern Alberta, and I'm currently here in Ottawa. These are the two sections I've been active in. And that's me. A week ago at work, I was shooting a video, actually, for a new product. So it will be released soon. Yeah, so just to show you that I'm a true young professional at work, busy. But yeah, let's go back to the start of the journey when I joined the YP team as a volunteer. This is Tushar Sharma. He was the YP chair back in 2015. And I was a member here among the YP team. This was at the Southern Alberta AGM. Yeah, I was very happy to see my picture there among the team. So that's basically me there. And the year after, I actually decided to get more engaged with the section, and I was the site chair in Southern Alberta, and I was presenting at the 2016 AGM the year after. And that AGM was a bit specific to me because I won my first IEEE award, and which got me really into volunteering and giving more and getting more involved, and got me hooked in IEEE basically. So to give you a sample of the YP events I started helping with and doing with my team, this is actually me here. Let me know if you can see my pointer, because I'll be showing pictures and pointing at the pictures. So yeah, this is me, and this event was an industry and speed networking, where in one table we put a professional and 3 students on the other side, and we give them 5 minutes for speed networking type of event, then they switch tables. So we had more than 20 professionals and 60 students. We also host industry mixers with this one with the Schneider Electric, and we also give certificates and awards to the students who won the IEEE Extreme programming competition. Yeah, this is part of the student branch and young professional industry mixers events. This is IEEE Extreme. We encourage students and young professionals to participate, and we had 1 year a team, I think, ranked among the, I think, 21st winners in the award, so that was a good achievement. Other events, we go outside, not only on campus. We visited the WestJet hangar here, and we learned about all the electrical engineering, mechanical engineering involved in this job, basically how they get trained and how they get certified to work on airplanes. And we discovered basically aerospace for civilians, that was the tour. We went for another tour to a hydropower generation site, and we did quite a few of these. Usually we are 4 carpooling students, and we go around 20 students. Usually we visit the hydropower stations. In Alberta, actually, there are solar stations, like solar farms, and you can see they are, buried in snow here, but they generate quite a good amount of electricity, because in cold weather, the efficiency of the solar panels tends to be high. So even with the small amount of light that we get in northern Canada, we still get a good power generation using solar panels. More events, partnering with a VLSI conference here that we hosted a parallel young professional panel at this conference, and we had basically graduate students participating in the panel. And if you see this picture right this side, the conference, they gifted us all the young professionals a development Bluetooth low energy board for free, which costs about $100. So we were very happy to be part of the conference. More events, visiting the YP team here, visiting the Rothney Observatory, which is part of the University of Calgary Physics Department. This observatory was used during the Cold War by Americans in northern Canada, and then it was repurposed for research purposes, and it's now part of the physics department, physics and astronomy department. So they have open doors once a month, and we go visit as young professionals. We visit the observatory. More events here, a series of entrepreneurship, basically successful graduates from our university coming to speak to us about their journey, how from new grads they launched their own business and their own companies. So this gentleman, he started his own company and was struggling from how he gets money and how to get funds and investors and all that. But he was successful towards the end to win a very high-level competition at Harvard University. And with that money, he actually started a company, and now he's employing about 30 engineers. More about entrepreneurship here with Jason Long. He started an educational program himself. He didn't want to do it as a professor. He did it as an engineer. So he started teaching students about embedded systems, and he launched a program. It's called Embedded and Embedded. So and now it's a very successful program. It's similar to Arduino development board. So more events here with the IEEE Day celebration. We host a barbecue every year, and we get more than 300 students to join our event. And we have cakes, we have burgers and sodas and varieties of food and fun and music and everything. So IEEE Day is a special celebration day among the student branch and the young professionals. This event also working with the student branch to host a sumo robotics competition, basically robots fighting each other. And we had 16 teams, and that's me here in the center holding the winner robot. And we got all ages from 10 years old to 30 years old participating, and we give awards, $300, $200, and $100 to the first 3 winners. I'll be talking more about amateur radio. Excuse me. Yeah, so, sorry. Yeah, amateur radio is one of the hobbies I personally am very engaged into. So this is David Garrett, my colleague at the University of Calgary. And me and David, we co-founded the Amateur Radio Club at the University of Calgary, and we've been hosting events back then. And this is one of the events where we had Raspberry Pis and the SDR dongles, USB dongles that we use to capture RF packets and decode them. And all the participants were able, towards the end of the workshop, to use the Raspberry Pi to capture an RF packet, decode it, and see what's the message in it. So this is my first visit to Bangalore back in 2017 during the Young Professionals in Space program. I was with David again, delivering the amateur radio workshop that we hosted during the Young Professionals in Space. And after the Young Professionals in Space event, we actually visited Team Indus startup, let's say, which is a private company exploring the moon. And it was a very insightful and really very inspiring tour that we had. And when we've been all over around Bangalore, we even visited Nandi Hills, and it was a great, great experience in Bangalore. So this is exactly a year ago, last November, the third version of Young Professionals in Space, which was hosted in Dubai, and I was there along with other volunteers and familiar faces. Some of them I met in Bangalore. They are returning again to a Young Professionals in Space event. And we also hosted another amateur radio workshop, and you can see the participants and the engagement of students. Another event that you mentioned in my bio there, which is Rising Stars. I've been really engaged and involved in Rising Stars organizing committee since 2016. I took students with me to the conference. Some of these students, I was the teaching assistant of their class at the University of Calgary, and I told them about the conference, and they joined me, and the team kept growing. Up to 1 year, I think we got more than 30 students from the University of Calgary, the IEEE Southern Alberta, to visit the conference. And 2020, I was the conference chair. So Rising Stars, I definitely invite you to check it out. It's the premier student and young professional event in Northern America. Now it's going global, so you guys can even sign in and join. And there is also a poster competition there where you can submit a poster with your research work to the conference. So coming to the humanitarian activities track, as I mentioned, I was the site chair and currently the IEEE Canada Humanitarian Initiatives chair. So I started hosting very simple events, just with my team, inviting speakers and getting to learn a bit and more about humanitarian technology, what are the fields of research and what people are doing. So one of the first guest speakers we had is Glenn Cutler. He's the director of the RFID lab at the Alberta Polytechnic School. So he's the director of one of the 3 labs in the world certified to develop RFID technologies for humans and animals. So, and the applications he spoke about were ranged from, tracking luggage in airports and construction and, farming, everything. So the applications of RFID technology that we learned about were really, insightful and very interesting. So this is, one of the first events that I hosted. More events related to amateur radio is the certification workshop. So before sitting for the certification exam and get your call sign and get certified to operate an amateur radio station, you have to do the certification exam. And we prepared students to do that. So we had a full room of students, and we organized a 3-hour workshop for them to learn about amateur radio, the basics, and we gave them material to read and everything. So, and from the 30 participants, I believe 17 sat for the exam, and all of them got certified. So that's how we started our Amateur Radio Club. And this is another event celebrating the Amateur Radio Day, which is on February 13th every year. And we hosted also another workshop. And as you can see here, the Radio Amateurs of Canada headquarters tweeted our event, and they were happy that we are active. And those are both my call signs for basic and advanced amateur radio licenses. Still with amateur radio, we participated in the Disaster Alley, a yearly event. This event is in June every year, and people like firefighters and first responders and everyone who's using technology basically to help in a disaster case will gather and showcase his material, like equipment and everything. So we were there as the Calgary Amateur Radio Club, showing that with amateur radio you can, establish communication in a few minutes, and you don't need big infrastructure, just a small battery, small station, and walkie-talkies and simple equipment. More events here. We invited Dr. Robert Thirsk, who is a Canadian astronaut with the record time in space, and he actually did 3 missions to the space, and I think 2 of them to the space station, the National Space Station. And also, I was there, me, Tushar, and David, and he gifted us this Alberta flag that actually flew on a Columbia mission and came back to Earth. So that was a very valuable gift that we got, and it's still in our amateur radio club on campus at the University of Calgary. So the event was very well attended, and Dr. Thirsk, he spoke about all the technologies he was involved in developing on board of the ISS, and all the medical and like several technologies, even using fire and everything. So yeah, so his talk was really inspiring. What else? So this one is the Capstone Project exhibition at the University of Calgary, and we were there to support students who had projects related to humanitarian technology, and we gave them micro grants from IEEE funds to help them. So some of the projects here, this drone is basically surveying fields of crops, and instead of the farmer himself going in the cold weather, let's say in Canada, to check his farm, he can just do it using a drone. This is a solar panel powered bus station, so it could be heated and connected also to show the bus arriving time and everything. So it's a kind of sophisticated or modern bus station that could be deployed in rural areas where there is no direct connection to electricity and all that. So that was one of the projects. We hosted more events on campus, such as the Meet My Robot. So we have a very active robot builders in Calgary, and we invited them to showcase their robots and basically talk about what they are developing. So we had teams from the first robotics competition showing their robots, and they actually did some addition to the robot, and they developed the robot to be a first responder too. So this robot, they developed this metal arm that could be used in case of like if you want to pick up anything dangerous, and you don't want to send people to do it, you can send this robot with the robotic arm. Some other robots here with the ropes that you can pull something with it, or in endangered areas you can send that robot. This airplane, actually it's a combination of a regular airplane and the drone that can lift vertically and then fly. It could carry 4 kilograms, which is the weight of a first aid kit, and many other robotics projects there. So this event in particular was published at the science.gc.ca, which is the Ministry of Science and Technology website, and it was featured there as the University of Calgary and IEEE event. This also an event which is a gathering with all students from all disciplines. Even this was hosted at the med school at the University of Calgary. Just a discussion, open discussion about the Sustainable Development Goals of the United Nations. So as IEEE side, we were present there to talk about what IEEE is doing and the contribution of IEEE in the Sustainable Development Goals. So more trainings and events that I attended. This was April last year, a training for the IEEE Move Track, the IEEE USA Outreach Move Track, and it's a 2-day training. So I attended that, and I got certified to be a Move Track volunteer, basically to be deployed whenever there is a disaster. But I'm based in Canada, so I haven't been deployed yet. Hopefully not. So moving to Ottawa right now, more events with the local amateur radio teams. Since I moved here, I got involved with the 2 local amateur radio clubs here, and I've been learning a lot actually, working with these volunteers. Many interesting projects that I'm showing here in the next slides. One of them is the BATC, the British Amateur Television Club, and it's called the Portsdown TV broadcast with a Lime SDR, Raspberry Pi, and the webcam. You can actually create a small TV broadcast channel that you can receive and decode and watch. It could be used in the humanitarian cases when you have a remote site to basically survey, which is being used in forests to check forest fires and wildlife and everything. So it's very useful type of project, and it could be powered using a small battery, and the range could be improved. It goes to many kilometers. So this was one good project that I've been involved to. This one is more experimental. It's called the Kerberos Direction Finding SDR. It's 4 coherent SDRs that you can put antennas and detect the arriving wave, actually, of an RF signal that you want to track and see from which angle it's coming. So they are open source projects. You can check them out and learn about them more. More events with the local amateur radio groups here. This is for it's called Fox Hunt competition, where they hide radio transmitters, and we actually have to go and look for them and find them. So we use these antennas manufactured from very basic material, which is PVC pipe and a tape measure. And also we use this attenuator that we built to tune the signal and not desensitize the receiver. So yeah, these are few of the amateur radio events I've been to. That are a bit more than those, but these ones I had good pictures of and I wanted to talk about. All right, so coming to the projects of humanitarian technologies I've been involved in. So projects at the beginning, as I mentioned, most of our YP teams members, we were international students, so we didn't really know much about the ecosystem there, like what are the needs and what we should do. And identifying the need was something we not struggled with, but we wanted to do correctly. So we invited senior members, professors, professionals, students to this event, and we had a brainstorming session just to understand what are the needs, the local need there in Alberta and Calgary, and how we as IEEE volunteers could be effective in addressing that need and be effective volunteers. So this event was, we invited a few people from Internet Society, from a local association or enterprise, like non-profit. It's called Light Up the World, and IEEE Canada as well, representative for humanitarian technology. And the ideas that we came up with during this meeting were, in Calgary, we have people with special needs that we can help with developing solutions for them. And also in the surrounding areas of Calgary, there are people in First Nation reserves that we can help basically doing activities with them and do some educational activities and deploy technology and everything. So in the rest of my presentation, I'll be talking about all these things. And I'm starting with addressing the need of people with special needs. And we were lucky to find a local maker movement. It's called Tikkun Olam Makers. And what they do is basically this, in line with our vision, is address people with special needs. And in Calgary, you can see the statistics. There's a very considerable number there with people who need solutions and they couldn't find it off the shelf. Basically, they need it developed on demand for them, like on measure for them. So we hosted the 2016 first Makeathon with 8 teams. So the team will be composed of a person with special need and 8 engineers. And the 8 engineers are from different disciplines, not only electrical. So, and the first workshop here in the pictures is matching the person with the engineers and his team. So if he needs a particular solution, engineers that could help him with that solution will join his team. And as I said, we did 8 teams of 8 engineers and 1 person with special needs. So this is how the competition went, 3 days, and the team which is able to come up with a functioning prototype and the solution for the person they selected will win. So I'm going to give one example, which is this gentleman here, Richard. He was living with his wife on the second floor, on the second floor with his family. So after he got into this accident, it was 2 years before this event. So he was struggling just to, go upstairs and downstairs, and also his wife couldn't carry him to bed. So the first thing, they could just move to another house on the main level, but his wife couldn't still carry him to bed and put him on his wheelchair. So this team developed this metal structure here. They called it lift, and with the motor and the harness, it will just pick up Richard and carry him to bed, like slide and slowly put him in bed. So, and they were among the winning teams. So different skills here, mechanical engineers, electrical engineers, and designers, and all of them, I think the average age was 25 years old, so very young engineers. These are the statistics and demographics of the participants. So we had undergrads, grads, faculty members, and engineers from outside the university. So the year after, we hosted the same event, and this is 2017 Makeathon, and we got double of the number of participants. So 16 teams here, and more solutions and more projects and more success. Here, just one example of Diana. She's the Women Engineering Student Branch Chair, and she was involved in the Makeathon, and she helped this gentleman to make this brace for him in order to sit more comfortably and read like from his tablet and his computer. So, and she wrote a site blog about her participation in the Makeathon. More solutions here, developing solutions for people with special need, and partnership with Nice Choir Association. They have this it's called lip sync. So it's used as a mouse to browse a computer or a tablet or a phone. It could be wired or with Bluetooth. And the way it operates is you can, with your lips, move it up and down and sip and puff to do right click and left click. And it's based on an Arduino, and the shell is 3D printed. So students could just assemble it. And in one day, this team assembled more than 24 lip sync device, and they donated it to the Alberta Health Services for free. So more projects here with the local First Nation reserve. It's called the Siksika Nation, and they are about an hour drive east of Calgary. So we've been visiting this First Nation tribe, and the first few meetings we had were with the Board of Education, and we asked them how we as engineers could be helpful to, enhance the student experience at your college and school. So at the beginning, they were very, agreeable, and they helped us. But we started up with a small scale. We didn't want to ask much because we were just, getting to know each other, and we didn't really wanted to ask for big things. So, and you can see here, actually, this project was featured as the cover of the IEEE Canadian Review magazine. So, as I said, we started small. They gave us this shed, this small room at the back of the school, and we had to clean it and empty everything, and we brought our equipment for educational activities. And this is how it looked like. So we started getting students and the kids basically to show up, and we started. This is Bruce. He's our guy. He's a senior member of IEEE, and he likes to teach and volunteer. So we worked with Bruce here. He was the main person doing these activities, teaching students basic engineering concepts like Ohm's law and mathematics and everything like simple that students would love to learn. He also went even further than that, and he brought them, coloring materials, and even had a workshop for drawing and arts, basically. So whatever they asked, he was very accommodating and helpful for them. So after that small room, we actually gained access to a room inside the school, and the activities started to grow bigger. So step by step, we got access to this workshop here, and we started getting machines. And it's a machine shop basically. After getting funds from IEEE and from the schools to start repurposing this room and making it as a machine shop. And here, this is a soldering workshop where we brought FM cheap receivers that you can buy online for like $5, and you can solder them and put them together to listen to FM radio. So we had a soldering workshop. This room was full here, about 50 students total. So at the same school with Bruce and the students from the First Nation, he set up this. So basically, Bruce is very into astronomy, and both astronomy, like optical and radio astronomy. So this is a horn antenna that he brought, and he was recording waves, galactic waves that were received using this antenna, and recording them into this computer, and he was doing amateur radio astronomy. So he was able to put together with students this posters here, and yeah, he took them to a conference to present the poster. This was one of the astronomy activity that we hosted. I will come back to more astronomy in a bit. This is a workshop also at the same First Nation Reserve at the Siksika Community Center, teaching how to assemble and maintain solar panels. We had more than 12 participants from the First Nation Reserve coming to learn about how to assemble and maintain the solar panel kit with battery and charge controller and solar panels and everything. So this is the second day of the same workshop, and they were able to assemble the panels and get the lights on and everything. So it was very successful. Yeah, coming back to astronomy, so we got this telescope here donated for free to the school, but the mirror was broken. So Bruce was very ingenious there to grind his own mirror and coat the layer on top of the mirror, and he was doing it himself with students from that college. So at the end, the telescope was working, everything was running fine. What we wanted to do, so as students, this team is the PES student branch and myself and another colleague. We went and we purchased this solar panel kit that we will use for something that I will show in a bit. So first of all, we purchased the solar panel kit. We took it on campus. We gathered students. For sure, you have to bring them pizza here to attract them. But it was a very serious event where we recruited students to help us assemble the solar panel kit. And this is how we got some space in the lab where we brought the kit and the panels and everything. And we were able to assemble it here on this board. And we took it to the First Nation Reserve. Let me mute this. So what they did is they built this small shed, which is a room where we had the telescope and a computer, and we got also internet connection, and everything is powered by the solar panel here. So it's a remotely accessed telescope that will be used by the school for educational activities, basically. And that project was published in the paper in the GHTC conference 2017. So it was myself and other students from the University of Calgary. We wrote this paper and that was accepted. This is the comment we got from the paper reviewers, which was really motivating for us, just because it's the only student team, no professors and no help from anyone except IEEE funds. We were able to get this project running. So this is when we went to present that paper at the Global Humanitarian Technology Conference. Myself and Sarah, she's the PES and the branch chair at that time, and we attended the site reception and we got to meet very good site volunteers there. Okay, so this is another project regarding internet access deployment for another First Nation Reserve. It's called the Musqueam, and basically we deployed internet access for them. So this guy, Bruce, he's the main person that was deploying internet for his community, and we helped him by giving him more exposure to people who could help him, like entrepreneurs and associations, and we invited him on campus. So Bruce was, as I said, the main person doing internet equipment deployment for his community. And this is to Sharon, David again, and myself. We went a few times to help him out, deploy more antennas and access points to his community. So he started to cover this small region here with this heat map with internet access. And just, I think, a year before this, he was just consuming 4 gigabytes of data, but a year after he was delivering more than 1.5 terabytes and even more right now. So this was back in 2018. Now he's covering a very important map of his community there and delivering internet service for free to his community. yeah, this is some of the equipment that we purchased from IEEE funds. So this is another project with Light Up the World, where they take students to deploy solar panels in many countries all over the world. But I was involved in a trip to Guatemala with Light Up the World, where we basically have to attend this one-day training to just learn the basics, and then we fly to our destination. So from Calgary to Guatemala City here, and this is me with the local IEEE site Guatemala team, where we went to explore the city, and we went to museums and historic places in Guatemala and Antigua. And then the team from Light Up the World, I went before everyone, just 2 days before, but yeah, after 2 days they arrived and I joined them. Then we went to deploy solar panels. So the first few days we deployed solar panels, we fixed actually, and we reviewed existing installations that were done also by students who came in the previous trips. So the first few days we just fixed existing installations like these ones. We upgraded solar panels, we rewired new installations, changed batteries and fixed phone chargers and everything. And then we deployed new installations. This one in the school, it's the city, the area, it's called Todos Santos. So you can see here a team. Even we had this guy who was a civil engineer. He was doing the concrete work. So putting for this mast, we needed a base of concrete. So he was the person who did that with the help of local community, of course. So these are the installations they did. We had both DC and AC power deployed, and this is the power panel here, and that's me installing it. And this is how happy everyone was when we flipped the switch and turned on everything, and we didn't get any short circuits. So no troubleshooting needed, everything worked, and everyone was happy. I had this signal booster with me that I put in the school that I purchased before the trip. I talked to the Light Up the World guys, and they told me the signal coverage is not that good. So I thought about bringing this signal repeater or amplifier to be used for reception, basically cell phone reception. And you can see here it's improving the signal, 4 bars, not bad. So yeah, this is the last day at Todos Santos. We removed the diesel generator here, and we installed clean energy solar panels. And this is by this time we became experts in installing solar panels. So this took us half a day just to do a solar panel and a few light bulbs in the community center. So yeah, in Guatemala we got to meet the local people and learn about the culture and visit their markets and, you know, taste the coffee and the food and everything. So it was very unique experience. This guy, when I was at the school there, he was coming there and he spoke decent English, let's say. And he showed me his hoodie, and with this logo, he said, "I'm working with Education for Change," which is an organization based in Oakland, California, and basically working with them to improve the education and the situation in his local school. So it was good to see local people also doing small initiatives and doing some great work there. What else? Yeah, this is, after we finished, we had this small celebration with the local community there. They played marimba for us and we had fun. We published a couple of articles in the Canadian Review magazine and the YP newsletter. Canadian Foundation also. Canadian Foundation was very helpful. They gave us also a grant to do this project. Here, another project in Guatemala. After I left, I stayed in touch with the local site team, and they did actually build. They applied for site funding. They got the funding, and they built this well to store water for a remote community, and they kept improving it, and basically providing clean water to a remote community here. So the year after I went with Light Up the World in 2016. The year after I didn't participate. I was busy with my PhD work, but this initiative kept going, and other students went to Peru this time to deploy similar solar panels, similar solutions to remote communities and to schools, and it was also very successful participation there. And they did the same thing. They wrote an IEEE site blog and another IEEE Spectrum article there about this activity. So these are some of the awards and recognitions that myself, Southern Alberta section, and the teams I've been involved in received. I have more than those. I don't want to brag about them. So, we are hosting the International Humanitarian Technology Conference, hopefully next year, in partnership with Region 8. I know that Region 10 has the R10 Humanitarian Technology Conference, and I was invited, but I wasn't able to make it. Hopefully next time. I want to, give credit to all the volunteers, teams, and persons, and everyone who helped me throughout my journey, and who had this amount of fun with the IEEE activities. Without them, this wouldn't be possible. So I'm very grateful to my team. And as a conclusion, what I learned is just, have fun, take benefit of your IEEE membership, learn skills that you might not be interested in, but when you see them, you will be interested in. Like astronomy, I wasn't remotely interested in that, but once I've seen people doing it, I was very interested in. I kept learning about astronomy every time. Discover the world, get to meet new people. Never, be afraid of approaching IEEE people. Just say hi, send an email, talk to them. They will help you. They will show you what to do if you don't know. So just approach people and don't be shy. These are funny things that I've learned. You shouldn't send spams, and you should send formal emails. Don't spam people if you have events, and don't be annoying, basically. I learned how to order pizza and order coffee and donuts and all that catering, so I'm an expert in catering now. And the communication, which is basically designing posters and how to promote events on Facebook and all that. So I've learned a lot, many good skills to summarize. So thanks very much. And again, thanks for the invitation. I'm very happy to address you this morning and this evening, your local time, and morning here. So thanks a lot, Bangalore.
Thank you, Anil. It was a brilliant presentation and very inspiring. Can we take a quick photo with Dr. Anis? I request all the panelists to turn on their cameras.
Sure.
Can we stop the presentation for some time so that all... Thank you.
Thank you, Anis. Thank you, Dr.
So I think, Anis, it was a great time with you, and any questions can be posted on Q&A. So it was really a nice experience, I can say, me with Anis, when we all met in space, right? YP space. So that was a great workshop and great memories, I can say, what we had with you guys. And that still retains memories for us. And this whole talk shows like how good you are into a lot of things here. And yes, it's a great kind of motivation what we have here. So seeing this, we feel like our events a little less. So yes, we will also gear up and we will cover all this. A nice kind of workshops what you had. You have covered almost all the possibilities, I can say. And any questions from anybody else?
Yeah, I see one question from Summer. So thanks, Denise. And how can one leverage IEEE YP membership? How did IEEE help you during your grad school and PhD? So leverage your membership. It's basically the way I see it. You have to balance both technical and YP and social aspects within IEEE. That's how I personally approach it. So YP and the affinity work, humanitarian for women in engineering also, and YP, these things. It's good to have that social connection and gather with students, like-minded people together and discuss your concerns and everything. And at the same time, a technical membership also is good, where you get to learn about the cutting edge research work and technologies being developed and the trends in the market and everything. So this is how I personally use my IEEE memberships. So I'm with IEEE MTT, and I tend to attend conferences, webinars, learn the technical side as well. So you don't see me having fun here and traveling or visiting and collaborating with students and all that. But in parallel also I get to work on my PhD work, my research, and use the technical side of IEEE as well. How did it help me during my grad school and PhD? In many ways, actually, because PhD could be like a tough thing to do in terms of it could be stressful, it could be heavy course work, research work, teaching, and all that. So campus could be boring, right? But if you have friends there and you can host events, and especially for us international students, because we couldn't work outside of campus or anything, so we only had study permit, right? So you will see many international students and even local, like Canadian students, getting involved, and it's good to connect with people, especially if you're a newcomer there. You don't know many people. Going to volunteer with IEEE will definitely give you more chance to meet people who are from engineering backgrounds, and you can easily communicate with them. So PhD, I don't know, it was fun. I would say I was lucky to be surrounded by great colleagues and a good professor and great IEEE section. Everything worked fine, I guess. So that's how I'll answer this question. Yeah. But having a balance between studies and volunteering is very essential. So during the weekends, I was doing IEEE work, and weekdays, a bit of volunteering on campus, and most of the time in my lab studying and doing research. So yeah.
Thanks for sharing, Anis. Yeah, it answers my question.
Great.
Yeah, a small token of appreciation from our end, because it's a virtual, we cannot meet you personally, so we are giving you virtual memento for a small memory. Thank you so much for being with us.
Thank you very much for having me, and I hope to see you in person in Bangalore, hopefully soon.
Yeah.
Thank you.
So can we go to our next speaker? Nicole, are we audible?
Yeah, can you hear me?
Yeah, Nicole, you're audible, yes.
Okay. Hi, good morning. Let me make, I guess I can, okay. I guess I can't actually share my screen, or?
Yeah, so access is not yet.
We'll be getting the presenter. Changappa, can you make?
I'll send you screen to you, and then Chingappa will give you the presenter rights.
Okay.
Yeah, so we have our next speaker, Dr. Nicole McFarlane. Nicole McFarlane is currently the PC Advanced Professor and Associate Professor with the Electrical and Computer Science Department at the University of Tennessee, Knoxville, TN. She received the BS and MS degrees from Howard University, Washington, D.C., USA in 2001 and 2000 respectively, and PhD from University of Maryland, College Park in 2000. Her research experience includes information and publication and CMOS MEMS integration for lab-on-a-chip technology. She's currently involved in developing more and more efficient nano applications for applications in portable, wearable, and implantable sensing, environmental monitoring, and nuclear science, and has published numerous papers on these topics. She is an associate editor for Transactions on Biomedical Circuits and Systems and the Open Journal of Circuits and Systems, a member of the IEEE Circuits and Systems Society Board of Governors 2018-2020 term, where she is the chair of the CAS Society Digital Communication Ad Hoc Committee and a member of the Women in CAS Young Professionals Steering Committee. We are very lucky to have you today, and Dr. Nicole is going to be presenting on advancements in circuit design and role of young professionals in it. Over to you, ma'am.
Thank you, and thank you for inviting me. I'm very happy to be here. Guess this morning for me, but good night or good afternoon for some other people. And so let me share. I think I shared the wrong one. Okay. So you guys should be able to see my screen, the presentation version.
If you can make it, I'm in presentation.
Okay. I think that's what I was. I think it does the wrong.
You can go display settings up in the menu and do switch. You see display settings?
Okay, it's on my other screen.
Yeah. Swap.
Yeah. Okay. And although my moved a little bit. All right, there we go. That should be better. Yeah, so thank you guys for having me this morning. So I'm going to give you, as I said, I'm from the University of Tennessee, and I'm going to give you a little bit of background on sort of my research, talking about sort of the advancements in circuits that my lab has made, particularly in the sensors arena. And then, at the very end, I'll talk a little bit about, how sort of young professionals have helped me in my lab and worked along with me to develop some of these advancements. So kind of what I do, we're looking at sort of miniaturization of things, right? Having things be wirelessly connected. And so this allows us to have sort of more portable devices. You can have portable medical devices, having a smart home. You can even talk about, having smart cars. Or having e-health, I think particularly with the pandemic, I think everybody's been thinking about how to assess your health when you're not in the hospital or at home. And so, these are the kinds of things that we're looking at. And so I always, I don't always, because we just made this graphic a couple months ago. So this is sort of showing how the different pandemics over the sort of last 100 years, we have sort of the COVID-19 now, and then, 100 years ago, roughly, you had the Spanish flu, and you sort of had these little bit of outbreaks as you went along. And so, this is just showing sort of fatality rate versus time, and sort of this actually kind of represents, the mortality rate as well. So there, being able to assess health, whether you're talking about sort of implantable or portable devices is always a good thing. You may also want to look at things like pH. So for example, if you're looking at, your blood, if it's too acidic or too alkaline, and this can be indicators of health issues, this can also be used for things like, water quality monitoring. So it has sort of a host of applications that you can think of. This is just a little bit more just showing all of the different medical devices, right, that are kind of on the market today, that you may not think about, but all of these are kind of circuits-based, right? They all require electronics. They all require some circuits, right? Whether we're talking about sort of CPAP machines to help you breathe, glucose meters for diabetics, blood pressure monitors if you're hypertensive, or ultrasound devices, which are used for, expecting women and for other applications as well. And kind of, one of our, I'd say, motivations is looking at the wearable market. As I said, with the current pandemic, I think wearables are necessary. If, for example, all you want to do is measure temperature, or you may want to measure the analytes that are in the sweat of the person, or you want to have a patch that's kind of just under the skin of a person. And so all of this is actually, I think, a very robust research area that people are looking into, whether it's in academia or industry. And so this is kind of a projection that someone made, of, what that market is going to look like, by 2022, what it's projected to be. And these are just, I think some of the wearables that are on the market or that are coming to the market that people are, researching and investing in. And I sort of like to throw this because this was what, I think kind of electronics and wearable things look like in, sort of 2002, so you had sort of your old phone and you had to connect things to it. And, now we're down to things that are, smaller, faster, and that are connected.
Dr. Nicole, sorry, so there seems to be a WebEx window on your presentation. Can you minimize or push it to the other side?
Yes.
Yeah, the exact.
Is it gone now?
Yeah, perfect. Yeah.
Okay. Sorry about that. We have too many windows open. So I'd say kind of the research motivation, so for my whole lab, kind of building on that, is we're looking at making devices that are implanted in the wearable that are reliable, and by reliable here, I do mean something that can be sort of FDA approved. For example, the Apple Watch was recently approved to measure heart rate measurement. You can buy a lot of devices that do a lot of these things, but they're not necessarily approved for medical use. They're approved for sort of more casual use. And so one of our goals is to make things that are approved for, actual medical use. So, and that's, if you're going that route, you're also concerned with things like power consumption. As things get smaller, right, if I want to have something wearable, I have to be concerned about how long the battery life is. I don't want to have, be wearing a watch that's measuring my heart rate and, I'm depending on this to send information to my heart doctor, and I can't, it only lasts, half a day, right, or only one day. So you have to think about what is that power consumption? How are we going to replenish that power? We worry about things like data transfer. How are we going to get that information off of our devices? And we also worry about things like security. If I'm talking about my health data or, just even where I am, how do I make sure that's secure and it's going only to the person that I want to? And as well as sort of materials, size, and flexibility, right? That's looking a little bit beyond, I would say, electronics and circuits, but it is something that we have to think about, because ultimately, if I'm going to make something that's going to be sold on the market or used by someone, it has to be packaged in a way that's usable for them. So these are some of the things that we think about. So as such, my lab kind of focuses, on sort of portable, low cost, highly sensitive, rapid readout, high throughput, miniaturized sensors that are based on circuits and electronics. We focus on trying to integrate multiple sensing modalities, and I'll talk a little bit about those, integrating signal processing into the sensor hardware and integrating things like encryption into the hardware. And I'll show you some of the results that some of the work that we've done in that arena. So one of the first projects that we've worked on is kind of based on neutron detection. So really this, I would say, is a nuclear detection type application where you're looking at, so you can think, for example, like having PET scanners, which is sort of a positron emission tomography, where you've got a particle, nuclear particle that comes in. It essentially hits a material called a scintillation material, and that material then gives off light, and you build an optical detector. So in our work, we focus not on, the source or the scintillation materials necessarily, but we focus on, how do we develop this optical detector and to read out electronics, and, in line sort of with our miniaturization theme, we're going from, this is an example of a fairly large scale neutron detection system using what are called photomultiplier tubes. And so what we're doing is saying, well, we can go from this sort of huge thing to something that's a little bit smaller, and the dimensions we're actually looking at are not, in this case, horizontal, so it's actually looking 3D. So it's actually kind of going from, if you think of going from an old CRT television where you had that depth to going to something that's a flat screen. So we're essentially getting rid of, all of these wires and these huge, PMT tubes behind there, and we'll just be left with something that's this flat. And so what we use for that are something called single photon avalanche diodes. So we've done, quite a bit of work on this. And so what I'll say is, the really important thing here is that what they've worked on is we've done this in what's called regular CMOS to give us low cost and to allow us to scale this up as need be. And our real advantage here that we've done is to actually make something that is tunable. So what you see here is this is just an IV curve. And typically, if I were talking about a photodetector, I would only have a single IV curve, so I would only have one of these plots, whereas for ours, we've added a extra terminal that allows us to essentially tune that IV curve. So you can have this multiple curves to choose from, and that allows you to tune sort of the characteristics of the device. We've taken this and made it to be into an array. So this here is an array, is actually a subset of an array of those devices, where we've actually put in what's called asynchronous readout to actually read out each pixel's location, because ultimately what you're trying to do is get an image. And so in this case, we're reading out a pixel. So this here represents an address. So this is telling me, that pixel 2 in the column here, right? And 3 in my row, so that's the actual pixel location, has actually given me an event and has recorded an event which will be correlated ultimately, because these are for nuclear detection, to some radiative particle that I'm looking at. We've also done some work in impedance sensing. So impedance sensing, I think somebody talked about teaching, having sort of Ohm's law and basic circuits. So really that's all this is. We're really just looking at taking your basic Ohm's law of V is equal to IR and saying, if I want to figure out what R is, so I need to either apply a voltage and measure a current, or apply a current, measure a voltage. And sort of the goal here is to go from, sort of benchtop instruments to something that's a single chip. There are lots of applications that we're looking at with this. We're looking at things like cell counting, so sort of lab on chip type applications. implantable applications. We're looking at wearable sensors, and so I'll actually just show you some the basics of these two. So there's a whole host of applications that you can do with this impedance sensing. So this is what it looks like for if I'm thinking of sort of cell-based sensing, or or I'm maybe implanting a device. So the idea is that I apply a voltage source, right? This is representing my cell. I've got 2 electrodes, and I'm just measuring the current through it. So I'm measuring sort of my change, whether this cell is here, or if it's here, right in the middle, or if it's changing shape. I have it represented as, a ball at this moment. If it was a little bit flatter or, slightly different in shape, then the impedance that it presents between these 2 electrodes would change, and then we can measure that. So, we've done a lot of work on this where we've used sort of multiple filters to do that measurement. We've done, having an ADC. So these were specifically, I think, current mode versions of circuits that we were looking at. And we were looking at current mode just because it's easier to do math in current mode, right? All I have to do is connect 2 nodes, and I can sum 2 quantities. So it's a little bit easier to do some signal processing if you keep things in current mode. And so that was one of the things we were trying to do. And so in particular, we were trying to do this for cells. And so this is sort of an example of why we cared about that. Basically, if you have cells on a surface, so it's essentially sort of a glass surface over time, when there's no electrodes, you get sort of 1 impedance. As you get cells covering the surface, you'll get an increase in impedance. And as these cells move, as they change, as they divide, then this impedance will change over time. So it gives you a really good way to get real-time measurements of what's going on. And you can use this for things like cancer research, right? So they're interested in, okay, if I have a culture dish of cells and I throw a drug onto it, does it kill the cells? How fast does it kill the cells? What happens? And so this gives researchers a really good way to figure that out. So in addition to looking at the circuits, we also have looked at sort of the front-end transducers because it turns out that you are limited with what you can do with just the electronics. So sometimes you have to add a little bit more onto it. So we've experimented with nanostructures. So these are carbon nanofibers. And so this is just a SEM image of what they look like on the right here. And what we've done is we've actually done sort of impedance measurements of these with so what you see here, so this is what it looks like sort of at the macro level, and as you zoom in a little bit more, and this is what it actually looks like under the microscope. And sort of this little variation that you see on the surface are actually the cells. And so we were able to measure the impedance of these cells sort of over time. From essentially going from a surface that had nothing to throwing the cells on there, adhering to the surface and spreading out, and essentially being good little cells. In addition to that, what we've recently done is use this also as in a wearable sensor mode. And so here we're showing this as a cardiac sensor. So that you're seeing. Essentially we have electrodes across the body. We've got some circuits. Here we're using just some comparators, XOR and SR latch. And we use this to actually detect the impedance, both the resistance and capacitance. And then we send that off wirelessly, and it can be, we just did it at a base station, but the idea is that, you would be able to send this off to a doctor, and they could, maybe monitor, let's say, the fluid in your lungs, right, to know if you're getting close to having pneumonia and you really need to go to the hospital, now, and shouldn't stay home. And so this is kind of what our device looked like. This was, so this is the chip we fabricated. These are all of the discrete portions. These are the electrodes, and we actually used some paint-based electrodes. It was just a conductive paint. So you can see here this is one of my students who I'll show a picture of at the end, essentially painting this onto filter paper, and then we attach that to sort of medical tape. And so these are very cheap electrodes, which was one of our goals. We wanted this to be something that, would essentially cost less than $1 eventually. And so this is it actually attached to the skin. And we were able to get measurements, impedance measurements of healthy people. We haven't done this for sick people yet, but we have been able to do it for healthy people. And this is just kind of showing, the extension of those circuits. So this is what we use as our base station. We just use a simple Arduino connected to a laptop to actually get our data off of this. We also used it, interestingly, for hand gesture. So we put it around the wrist. So we took our circuit and we said, let's put it around our wrist and try to see whether we could tell sign language. So we were using American Sign Language, right, where you can say A, B, C, or D. And we had 13 electrodes. So what you're seeing here, these are 13 electrodes around the wrist. And we're sensing that impedance, which tells us, which we can use to then say, okay, I've recognized that the person has said letter A or letter B or letter C. And, this is actually a pretty interesting thing because people that do sign language actually, particularly in, now when they can't do they can't do face-to-face classes, actually having Zoom is a problem for people who are deaf and hard of hearing because they, if you think about it, whether it's Zoom or WebEx, right, all of our pictures kind of get smaller. And so it's very hard to see what the person is actually saying because they have to sign to say it. So something like this could actually help those people interpret what the other person is saying a little bit easier. I kind of mentioned that one of the things that we care about is security. So encryption is really the idea of saying, I've got a plain text message and somehow I'm going to encrypt it, I'm going to secure it, so I'm going to send it as some kind of coded message to someone who has an associated key and can decrypt that and be able to read my message. And if you don't have this key, then you won't be able to decrypt it. Okay, and we think that this is important because what I've shown before is that we're doing, kind of trying to do wearable devices. And so if we're going to do a wearable device and we're going to be sending things off wirelessly, I do need to care about how this is done. Currently, it's done, using microprocessors, or you're going to add or you do it in software, and those are very power hungry. And so if I'm trying to do sort of a wearable device that's very tiny, I really need to reduce that power. And so what we're working on is kind of making that be integrated with the sensor itself. So we're trying to do it in the hardware with the sensor. So that's kind of the difference. We've kind of chosen to start using what's called chaos, right? So it's probably exactly what you think it is, right? So it's unpredictable, it's sensitive to initial conditions, but however, under certain conditions, you can do the math for it. I didn't do the math, someone else did the math. You can show that if you have two chaotic systems, that if they start with the under certain conditions, all right, if they're, and for example, in our case, a shared state, they can actually produce a correlated response. But they have to be, those two systems have to be correlated in some way. And so this has been around for a while, and really all we've done, so this is, I know, a very mathy slide. It's really just a system of differential equation that describes this, plot here. And so what we have focused on is saying, well, these are already described in literature. Can we take these and realize these in circuits? So we're really saying, how can we take the ideas that have already been presented in math and realize them using our circuit knowledge? And so this is sort of a system diagram of what these differential equations are like. But I'll skip that slide. Ultimately, it really turns out that I can implement them as just these circuits. So I can implement them with kind of integrators and differentiators and multipliers because as a circuit designer, I know how to do that. And so what we've done is we've tested this using a temperature sensor that we built. So all of these circuits on the left are a temperature sensor. If you're not a mixed signal circuit designer, don't worry about it. All you need to know is that for this portion in the red, at this output here, I will get a frequency output. So I get a pulsed output that kind of looks like this down here. That's directly proportional to my temperature. So as my temperature increases, the frequency of this signal increases. And these circuits here, so this is my encryption circuit, I will get a signal that looks like this out of that encryption circuit. And essentially, I've hidden what my actual temperature is, and I can send this off wirelessly, and only the matching circuit, right, on my receiver can actually detect that signal. And so this is my recovered signal. It doesn't quite look like this. However, if you do sort of basic thresholding and averaging, you can recover your digital signal. So, this is actually what that board looks like. And so actually I had, some undergraduate students actually helped us with this PCB board. Actually, we had some undergraduate and high school students that helped us do a lot of this work. And so this guy here is our temperature sensor. So it's, relatively simple. And then these two are implementing the circuits that I showed on that previous slide. So this guy will encrypt it. And then it's sent off, and this guy here on the right will decrypt that signal. So we, of course, decided to do this with an integrated circuit, and so we were able to actually show that. And so I think this is actually one of the very first integrated circuit implementations that someone has shown with an actual sensor. We've also done, I think, as I mentioned before, pH sensing, and so this is another work of one of my students. So with a pH sensor, if you've ever done, I think most people, if you're an engineer, have probably done some kind of basic chemistry, at least, so you know about measuring pH, right? So really all you're doing is measuring the concentration of hydrogen ions. Typically, you'd use some sort of glassy bulb-based system. That's kind of the gold standard. And so what you can do is use something called an ISFET, which is an ion-sensitive field effect transistor. And so how that works is, so on the right here, this is this guy here. So you see where it says source, gate, and drain is a transistor. On top of that, in integrated circuits, you typically have what's called a passivation layer. So what you do is this gate is left floating. This represents metal. And then this is the top metal layer in that process. And then these represent the passivation layer, which are made of essentially silicon dioxide, silicon nitride. And so this surface actually is very sensitive to hydrogen ions. So if I've got a solution on the surface, and I have, let's say X number of H+ ions kind of close to the surface here, then it will affect the charge that I have in the channel of this transistor. And so what that corresponds to is that I will see a change in my IV characteristic for that transistor. So that's what you see sort of down here on the right, where I've got different pH. So this is actual experimental measurements where we did, the buffer solutions for pH. So this is the chip, and we just use a pipette to put the liquid on the chip. And so this is what that IV curve looks like for each of those different pH values. We do also, I should say, this is the actual chip here. These are the kind of electrodes that you see. And we do have to protect these bond wires because I think we all should recognize that liquids or any kind of water with electricity is probably not a good idea. So we usually have to encapsulate these bond wires with some type of epoxy so that they don't get wet and short our circuits, because that would be a very short end to any experiment that we're doing. So with these ISFETs, they respond differently to different pH. And so we can make circuits with them. So on the left is just, in this case, a differential circuit. We actually made this into a portable sensor. And so the actual circuits that we designed, so this is probably, I think, maybe 200 microns on the side for this actual circuit, and that's in this chip. And then we put it on a board with, we added an ADC, we added a markup processor. So in this case, we just did an Arduino to actually do some of the calibration and convert our measured output voltage to an actual pH. And so this is just what some of our results looked like with that. So, sort of across pH and how that voltage actually changes. And we also did this with standard buffer solutions, just as always as a sanity check of things. So we kind of tried to improve on that sensor. So what you saw in the previous green, our PCB and our portable sensor, was that we just had a circuit and we had to have an external ADC and a microprocessor. And so, as I said before, we're trying to make everything miniaturized. So we essentially got rid of this ADC and made it into put all of that on chip. So that decreased our size quite a bit. So this was about a 10 by 16 centimeter board, and this was reduced that by 11 by 11. We still actually want to reduce this a little bit further, which will be what this slide is about. And so we've actually gone to adding a microprocessor onto it. So instead of having the microprocessor off chip, which is, we're essentially using our Arduino to do that just because it's easy to use. We decided that we wanted to try our hand at actually putting this on chip. So we took our same circuit, we just added a counter, and then that goes to our microprocessor. And so this is what that chip kind of looks like. This is the sensor with the counter, and we used in this first run, we just tried it with a 8-bit MIPS processor, which is just an open source processor that you can use. You have your choice of processors, of course. And this is sort of what our results of that looks like. So we were able to measure our pH using this system. And so, some other projects that we've worked on are diabetes care. We looked at improving sort of your insulin bolusing by monitoring your bowel sound measurements. And the way, to think about this is we went, if you ever go to a doctor, one of the first things they may do as part of your physical is just, take their stethoscope and actually just listen to your listen to your stomach, right? So they kind of listen to a lot of different things. And so that's actually what we were trying to do here. So we just took a piezoelectric film with we worked and we built the circuits. The circuits actually had, I would say, sort of feature extractors. And so we actually did this test. So this is what our first prototype of this looked like. This is a piezoelectric sensor. This is our board. You will notice that this is big because in our first pass of most things, we will always have, we give ourselves room for error, which is, I think, one thing that you always learn. You give yourself as much tunability as you can. And so in the first pass, we did keep a lot of our tuning off the chip and gave ourselves a lot of room to change things. And so what you see here is this is the raw vowel sound. And so these are outputs at various points in the circuit that we use to actually recognize, has there been a sound or has there not been a sound? And, we were able to pretty much fairly accurately detect if there was a sound or not. We've also, along the diabetes care, have looked at doing glucose sensing. So this is, I am showing a chemical reaction here. This is actually how, if you go buy a glucose meter from the store, If you know anyone that has diabetes, they usually have sort of a test strip, and then there's the electronics part. So this reaction is what happens on the strip. And the electronic part simply reads these 2 electrons that you're measuring using a circuit known as a potentiostat. So we've kind of worked on both of these. So in our case, we've developed a circuit along with wireless readout, sort of in line with making our things implantable or wearable, and are really able to tell the difference, the change in current as a function of our output frequency. And we, of course, tested this. So we actually tested this with something known as vertically aligned carbon nanofibers as our electrodes instead of using test strips. And the reason we use those is because they can actually give you higher resolution. I can measure more current because I have a much higher surface area than a test strip, which is just very flat. As well as if I'm making something implantable, carbon is a very good material to use because it would tend to be biocompatible. And so this is just some results that we got of glucose versus our output frequency using our circuit with these carbon nanofiber electrodes. So kind of in summary, I've given you like I would say a very broad overview feel for what goes on in my lab at the University of Tennessee. So I've shown you a couple of different sensing modalities that we've done. So, we've done optical for sort of radiation type sensing. You can also just do it for imaging. We've done electrical, which is sort of the impedance sensing, right, which we're using for both cell-based sensing, so looking at cell cultures, as well as looking at, for example, lungs and fluid in your lungs. So for, example, for testing if you need to go to hospital, if you're, getting serious with any infection. You can also use it for cardiac monitoring. People use it actually a lot as well for, I think, looking at body fat as well. We've done a lot of electrochemical sensing, and so I play sort of the pH sensing within that role, so you can use that for, figuring out what is your blood not small, is it acidic, is it too alkaline, what's in it. You could use it for sweat. You can use it for just, if I'm giving someone water, is that water clean enough for them, right? Is it of appropriate, is it at an appropriate level? And we've also used it for glucose sensing. Of course, I showed glucose sensing, but the principles can actually be applied to things like neurotransmitters and a whole host of other analytes, pretty much anything, almost anything you can think of, as long as you can think of the system. And so we accomplish all of these using circuits. In some cases, we do use some other materials. Usually we're using carbon-based materials, so as in our carbon nanofibers that we're using for the electrochemical sensors, or the paint, the conductive paint that we were using for our impedance sensors. And so ultimately, I showed you all of this, so I didn't do all of this by myself. All of this was done in conjunction with, other young professionals who are in my lab. And so this is Kanda Karmamunza. He did a lot of the work on the electrochemical sensing circuits, as well as doing the carbon nanofibers. Speed did a lot of work on the neutron detection and building our single photon avalanche diodes. Shamim also did extended that work on the single photon avalanche diodes. Ava actually did a lot of work on the impedance sensing and the security. Bennett has been doing a lot of work and helping us with coding a lot of these things and building our PCB boards. Shagoya has done a lot of work on pH. Wes has helped with the security. Aminul has been doing a lot of work on some new carbon nanostructures that we're working on. Kendra has done wireless work for us. And Sharam has done a lot of, is continuing a lot of our optical sensing. And so if you think about kind of my work, I would say all of them have, our work is electronics and circuits, but it's not really possible for us to do without talking to people outside of our field. So we spend a lot of time talking to people who are in biology or who are in chemistry, right, or who are doctors, because we don't actually understand, for example, how lung fluid in your lungs actually leads to pneumonia, right? What is that process? So a lot of what we do is saying, well, we do want to build circuits, but the only way we can use those circuits to solve someone's problem is for us to actually understand that problem. So I would say a lot of what their role is that they actually spend a good amount of time learning from other fields and saying, how can I do things better? How are they doing things now, and how can I do that better? How can I improve that? And they also have to, I think as the previous speaker said, go to, a significant amount of, they've got to learn from others within our field as well. And so usually that takes the way that takes form, I think particularly in an academic setting for us, is that they go to conferences a lot. So they do go to a lot of conferences, sometimes whether or not they're presenting a paper. And that's how they learn. And sometimes that's how they get ideas. Sometimes that's how they just meet other young professionals, and they may say, oh, you're working on a circuit to do X. I'm working on a circuit to do Y. Maybe we can put those circuits together and it'll be something cool, right? So really sort of getting that networking going for that. Because I think that's a lot of what our work in our lab is based on. So with that, I will end, and I would be happy to take any questions.
Thank you, Dr. Nicole, for this insightful presentation on circuits. Audience, if you have any questions, please post them in the chat window. We can take them.
So I think, Nicole, it was a great session where it was a lot of technical things where it's so clear. I mean, it is so simple, and you made it, you conveyed it so well to the audience. That's what I feel, because it was really a great session, I can say. And thank you for being with us and accepting our invitation and being a part of this global summit and making it a successful. And can we have a group photo? Can you just stop sharing the screen?
Am I still? Let's see. I don't think I'm sharing.
No, you're not sharing.
Yeah.
Request everyone to turn on their video so that we can click the photo. Okay.
Yeah. So, Summmit, could you take over?
Thank you. Yeah. So, Chakapa, could you present the appreciation, Nicole?
So, it's a small token of appreciation from our end, because we are not meeting you physically. So, virtually, we want to give you a small token of appreciation, a memento, virtual memento to you. So, thank you so much for being with us and giving a great insight on your talk. Thank you.
Thank you for having me. Hopefully I get to do this in person at some point.
Yeah. So, Changappa, can you just share the screen of the contest? So to the audience who are here, as I said in the beginning during the inauguration, we also have something called like a social media contest. So if you're there here with us here, even virtually, you can take the screenshot and tag us on IEEE YPGS 2020 and IEEE Bangalore YP, and you can post the screenshots on your social media. And we have a contest where we are giving out certain prizes for the people who are participating in the contest. So make sure you prepare a poster on the theme like the future leaders of YP, and you post it in your social media, share it with your friends, and also you can make sure you get maximum likes so that you have a lot of people who are liking you, and you even get a lot of cash prizes also from us. So the theme is young professionals are future leaders. So whatever you feel like how young professionals can become future leaders and how they can contribute as a future leader, you can always, make a small poster of it and put on your social media, and but don't forget to tag us, because only if you can tag, we can have a track on it, and make sure like you grab away some prizes here from us, and we are awaiting for your response here, and we already have people like started who are sharing and tagging us. So that's really nice, and this was our last session for today, and thank you for all the participants being with us. And we have a small feedback link here, so kindly don't forget to fill that before you log out. And tomorrow we have some more great sessions, I can say. So morning we are starting with sessions from speakers who are from NASA. So we have Mr. Quentin Bond. So I think you should really not miss Quentin Bond, because he's a great motivational speaker. That what even I have met him personally, and he's going to talk like how you can be the best what you are. And we also have NASA Chat from NASA. And past that, we have all the YP chairs from India. We have 6 different chairs from India, YP chairs. So we all will be having a nice. They'll be sharing the work what they're doing, and also we have speakers from White Technology. He's from Sweden, Taimur Abbas. And we also have a workshop on data analytics, cloud data analytics, and AI and ML. And I don't think you have to miss this opportunity of attending this workshop and learning a lot from Nicole Mathur, who's from Amazon again. And we have panel discussions in which we have people from the different young professionals, and also people from different regions, chairs of young professionals, and we have a small round table meetup. So I think tomorrow we will be starting with a bang in the morning at 8:30. Don't forget to join us, and we already shared the new link for tomorrow. So kindly do join us, and that's for today. Thank you all for being with us.